The first thing we have to do while using Excel and solving a linear programming problem, we have to set up a problem. By setting up a problem, we mean that we have to tell Excel exactly what kind of problem are we looking at and where do we need its help to figure out the answers to the question we are interested in knowing. So there will be certain rules that I will be describing as we move along, and I would want you to make a very close note of those rules because those rules apply to any kind of linear programming problem while you're setting it up and while you're solving it using Excel. Now, the first rule about linear programming or setting up a linear programming problem in Excel is that you have to label everything because you need to know what kind of information you're putting into each cell. If you don't label everything, you will probably go back and get confused on what you're trying to do. So let's start off by building some labels. Our problem that we're trying to solve is a product mix problem. So we will create the first label, say product mix, and our product mix contains a normal lawnmower, and we will write that down. And we also have a racing lawnmower. And you must be looking at it and see, oh, these labels don't look that good. So we are going to use some Excel options to make them a little more readable. So if you go into your Home tab, we need to do two things. We have to make sure that this text is within the cell size, and also we want to make it bold to look like a label. So let's make it bold by going into the font option and clicking that B. This is an option for bold, so you will see it becoming bold. And we also want to contain this text into each cell, and we're going to use this option called wrap text. So if you click on that, you will see that all the text in each cell is now contained within each cell. I'll also use the center align option to make it look a little better. We can also adjust the text or labels by dragging each cell like this. Okay. All right. Now, for each product mix, we are interested in knowing the number of each product that we want to make. So I'm going to create another label right underneath product mix called number made, make it bold, center align. Now, we don't know this yet, and we want Excel to figure that out for us. So the color convention we're going to use in this class for linear programming is that if there is a cell that we want Excel to fill out and which is qualified as the objective function cell, we are going to color it as yellow, and we're going to keep it empty because we want Excel to fill that for us. We have some information about our product mix, so the next piece of information we are going to put in is the profit. I'm going to create a label for profit, and we have this information. So for normal lawnmower, we are selling it for $600, and the racing lawnmowers we are selling it for $800. And we are going to change the text type or the data type of this text. If you go into your Home tab and go into your number option, there is a little $sign. Just click on that. So it's going to look like an accounting number if you click on that option. We have some resources that we have to enter, including engines and labor and tubing. As these are labels, I'm going to make them bold and center align them. Now we have the information that how many resources each type of lawnmower requires to be completed. We know that each lawnmower requires one engine, so I'm going to enter 1 for each type. Normal lawnmower needed 20 labor hours per piece, and racing lawnmower, is more complicated, needs 30 labor hours to be built. We need 20 feet of tubing for each normal lawnmower and 16 feet of tubing for each racing lawnmower. That will help us complete this piece. So the next thing we need to set up is our objective function. So what is our objective in this whole problem? The objective of this problem is no matter how many lawnmowers we end up making and given the profit for each type of lawnmower, we want to maximize our profit. Always remember, we are a business, we want to maximize our profit, so this is our objective. And we have to create a space for our objective function. So we are going to select cell D3 right here, and we will create our objective function. Now our objective function is going to be a simple sum product of the profit of each type of lawnmower along with the number of lawnmowers that we will end up making. So the function we are going to use in Excel is called a sum product. We're going to type it in. Every function that we enter in Excel starts with an equal sign, and that is a rule, so you might want to make a note of it. So equal to sum product. And in sum product, as soon as I'm going to enter my parentheses, you will see that it is asking for arrays. Now, what is an array? Array is a fancy name for your data that is put in sequentially in Excel cells. For example, these two yellow cells is an array, and I'm going to select these two, and I'm going to put a comma, and I'm going to put my next array, which contains the profit. Now, you must be wondering, why did I enter these two cells? Well, my profit is actually the number of normal lawnmowers multiplied by 600 plus number of racing lawnmowers multiplied by its profit, which is $800. And that will be my total profit. And this formula is doing exactly the same. I'm going to close parentheses because when you are entering a function in Excel, a function starts with an equal sign, the function name. You open parentheses, put in your parameters, and then you close your parentheses. That's an indication for Excel that your function is complete. And we are going to click Enter. Now, at the moment, we don't have anything in our yellow cells, and that's why each profit is being multiplied by 0, and hence our answer is 0. So let's test this out a little bit. Let's say I'm going to put a random number of 5 in normal lawnmowers, and you will see that the objective function cell is changed to 3000, which is correct because 5 multiplied by 600 is 3000. Let me put 1 here, and nursing lawnmowers is going to become 3800. So apparently our objective function formula is working correctly. So I'm going to clear those, and as this is a profit, I'm going to change its data type to accounting format by clicking the $sign. And in this class, to identify our objective function, we will be using the color green. So I'm going to go into my font area and fill it with green color, just to make it easier for us to identify it. The next step for us to do is to set the constraints limits, because we don't have all the engines or labor hours or tubing in the world to make these lawnmowers. So to set our limits, I'm going to create a label for my limits, and I'm going to say limits right here. And for engines, I have in total of 75 engines. I have 2,000 labor hours, and I have 3,000 feet of tubing. Now, as you remember from the previous video, that the constraints have two sides, the left-hand side and the right-hand side. The left-hand side of the constraints are representing the total resources consumed, and the right-hand side represent the total amount of resources available. So these are the total amount of resources available to us. And I'm going to use the red color to represent that. So let me just fill it up with red. Now these empty cells that you're looking here right now, this is the left-hand side of our constraint, and they will be the total resources consumed. And we don't know yet because we don't know how many lawnmowers are we making, and the number of resources consumed will depend on the number of lawnmowers that we'll end up making. In other words, we want Excel to fill these in for us. To help Excel to fill out the left-hand side of the constraint, we have to create a link between the left-hand side of the constraint and the number of lawnmowers that Excel would suggest us to make. So we're going to use a simple formula, just like the one we use for our objective function, is going to be equal to the sum product, and we're going to use, as this is the left hand side of engine, so we know each lawnmower is going to use 1 engine per piece, multiplied by the respective number of lawnmowers that we will end up making. Okay, enter. And let's test out the left hand side of this constraint. So if we make 1 normal lawnmower and 1 racing lawnmower, so this cell comes to 2. That means that we, out of 75, we are using 2 engines. Okay, so it's working fine. So I'm just going to go ahead and clear out my yellow cell. All right. For the labor, it's going to be the same, equal to sum product, labor hours used for each type of lawnmower, comma, number of lawnmowers used, which is the yellow cells, close it. And same thing for tubing, equal to sum product, tubing used for each type of lawnmower, comma, number of lawnmowers made for each type. Enter. Now we will be, to distinguish the left hand side from the right hand side of the constraint, we will be using the blue color. So I'm going to go ahead and color it blue and center align it. And this column I'm going to call the column for totals. Now there you have it. We have successfully set up our product mix linear programming problem on Excel. A quick review. We have all the labels in place for the product mix, the number made, which we are interested in knowing, and Excel has let us know, the profit for each type of product, the label for each resource type. We have our objective function in place, which we are interested in maximizing. And then we have the left-hand side and the right-hand side of each type of constraint, where the left-hand side represents the total resources consumed, and the right-hand side represents the total amount of resources that are available. So let's move on to now setting up the solver in Excel that will actually solve this problem.